Welcome to Duality Check, the podcast where two brothers embark on a thrilling journey through the realms of scientific inquiry, the enigmatic mysteries of the past, and the uncharted territories of spirituality. Join us as we explore the wonders of our world and beyond, while we embrace the roles of curious bystanders rather than experts. Together, we'll unravel the intricate tapestry of existence, blending the dichotomies of knowledge and wonder. Get ready to question, ponder, and delve into the dualities that shape our understanding of the universe on Duality Check. I'm Drew.
And I'm Dean. And today's topic for the first episode of the show is we're going to be talking about science. And we're going to talk about where are its limits, where are its blind spots, like where are the areas that science is kind of hung up. I think it should be a fun episode today.
Yeah. Maybe we talk about a little bit of like what we want to accomplish with this podcast too.
Yeah. So the name is Duality Check, which I like it because the word duality to me means a lot of different things. Like it can mean, well, I mean, it's used in like science today as like duality. Dualism is this idea that there is a sort of materialist physical system that is our body and brain, but there's this kind of special something of like spirit or the hard problem of consciousness that we have a hard time explaining. And a lot of scientists and philosophers are stuck with this dualist view when a lot of other scientists want to reduce it all to materialism.
Yeah.
That's one use of the word duality, but the other is I like the idea of thinking of duality as this, different ways of approaching learning about the world. You know, you have the scientific method, but you also have like the spiritual and direct experience method. Yeah,
the more experiential view of having experienced the things, therefore it gives you a different view of the thing other than just running tests.
Right. And then another read on the word duality is duo or two. Because there's two of us.
There's
We're
two
brothers.
of us. Yeah.
Two brothers having a podcast.
That's right. We're going to be talking about a lot of science and mysteries and
our goal is
to
explore all these weird and wonderful ideas. We want to cover scientific topics. We want to cover that type of stuff, but we also want to cover the mysteries. We want to talk about pyramids and UFOs and
ancient use of psychedelics.
Yeah, exactly.
Chakras, dragons.
We're going to talk science and we're going to talk woo-woo.
Yep. And we're going to mend them, kind of give our own take on what that means for our lives, right? Like what it means for just the average human being and how science and the spiritual aspects of life kind of give us all our templates that we go by every day, right? Like we all have experiences of both.
Right.
In some way or another.
Yeah, we all experience science when we use our cell phones all day long. But a lot of us have, these weird mystical experiences, dreams, and you think about or talk about someone and all of a sudden they call you.
Yeah. Just it's going to be interesting. And today's topic is science. We're going to start off there.
Yeah. So I got a few topics written down here that I want to explore.
Okay.
It's a lot of the stuff that is at like the bleeding edge of science. But stuff that science has really been struggling with, and I want to kind of explore what science kind of thinks the state of it is, but also some other weird random theories that may account for some of these things too.
Let's
just have some fun.
And I'm probably just going to be commenting on a lot of the things he talks about.
Well, also
I'll give some I
want to lay
tidbits.
out that we are not experts.
No.
Neither of us have PhDs or college degrees. We're very much bystanders and all this stuff. We're your average internet folk like all you out there. We just like to learn. We like to talk about stuff. We like to throw ideas around. So
yeah,
please.
We've all experienced one thing or another that, makes us have an inspiration to dive into these topics. So that's where we come from a little bit. Is just
don't take us as some sort of gurus or anything. And that'll obviously, that'll
translate.
Be obvious enough as we're discussing things like, these guys don't seem to know what they're talking about. Well, you're right. We don't.
You're right. So what do you got?
All right. So the first thing I want to talk about is this dark matter and dark energy, which I find incredibly fascinating. So when you look into like astronomy, cosmology, and the group of scientists who are trying to explain like, where did everything come from? Where did everything start? How do we explain the universe we see around us? There's these two things that are, they're talked about so often that a lot of people maybe misunderstand and think that science has a much better idea about what these things are, or some sort of evidence that they are what science thinks they are, when in fact there's a whole heck of a lot we don't know, and it's just theories at this point.
It's funny that you say when in fact, because fact and theory are completely different things.
Right. Yeah, so like a fact would be like you can take a measurement, you can drop an apple and measure its starting point and its ending point and the bounces it does, and write all this down as like a fact of what happened when you did this experiment.
Right.
But the theory is, how do you explain that behavior and what causes it to do that? And so a lot of our theories have, a theory is something with some sort of evidence, or the formal version of the word theory, not in the colloquial use, like in the scientific use.
Yeah.
The word theory is like, it's like an idea that has evidence to back up somewhat. So it's kind of upgraded from like a hypothesis or just an idea or a speculation to something a little more formalized.
Yeah, it's basically something that has evidence to start to understand it, but there's still aspects of it that cannot be.
Whereas like a law is even higher grade than like a theory, right? So like a law would be something like, the laws of motion, that every action has an equal and opposite reaction. Like some things are so well understood, quote unquote, because we know that they happen every single time. There's no exceptions. But just because we know that something happens every single time, and we have the math to describe how it happens and how you can predict how it will happen, you don't necessarily always know the why.
Right. There's always the why.
But anyway, so let's talk about dark matter first.
Okay.
So dark matter came about as a theory when we're pointing our telescopes out in space and we see these galaxies, these crazy spiral galaxies, all these different shapes. They're trying to classify them. And we get Einstein's theory of gravity, which really helps us to refine what gravity is and whatnot. But there's a problem when we're looking at certain galaxies. So essentially what happens is scientists have these like ways of like looking at a galaxy and sort of estimating how much mass is in there by like essentially how bright the galaxy is my understanding.
Okay.
And so you can say, okay, here's this galaxy, there's X amount of stars in it, there's this much mass total in that galaxy. And so then they try and draw up the math to explain all of its movement. And they notice the rotation the inner stars rotate according to our understood laws of gravity.
Mm-hmm.
There's nothing super mysterious about the inner stars and their speed of rotation.
So when you get further out to the end of the spiral,
yeah, so you get out to the edge of the galaxy, and the stars out there, according to our theory of gravity, they're moving too fast. There's not enough gravity in what we can see and observe about that galaxy that explains how fast these outer stars are moving. And so they need more mass. They need something to explain why there's more gravity causing those stars to rotate faster.
So, and they haven't come up with other,
Well,
so the term dark matter, like,
yeah, the term dark matter is like, essentially the first theory is like, oh, well, there's probably just stuff out there we can't see yet.
Yeah.
It's matter, but it's dark, because we know matter is what, matter and gravity are interlinked. The more massive an object is, the more gravity it has. So they just figure there's some sort of matter there that our telescopes
not
aren't
detectable
advanced
by
enough
light
to detect. Right.
Because matter, we know, is detectable by light, like light bouncing off of it.
Right. But light it's got like a spectrum, right? So all the way, you got the visible light spectrum, but below that you have infrared.
Yeah.
And down, and then above you also have, ultraviolet and X-rays and all these things above. So we have different telescopes that can look at those different,
the different frequencies.
Right. So they'll look at a galaxy with all of that, and still with all of that, they don't come up with enough matter to explain these stars on the edge.
Got it.
So the one theory I know about is called WIMPs, or weakly interacting massive particles. It's a type of particle that doesn't interact with other matter, like electromagnetically. And it doesn't like give off light, reflect light, or anything like that. But it does have gravity. It interacts gravitationally
with the light,
with other matter in the galaxy.
Oh, gotcha. So it's attracting and
right. And they sort of think there's like these halos of dark matter around galaxies. I've heard it explained as
like, so that means like on a plane of matter, it would be like a ring, like a thin, like a ring. Wait, how is that?
Yeah. Again, we're not experts.
I don't know. Okay.
But it's interesting because when they add up all the, look at all the light, all the galaxies, they add up all this matter, and then they add up all this, what we need as quote unquote dark matter to explain how everything moves. And it turns out there's way more dark matter than there is matter, like by a long shot.
So basically dark matter fills in all of empty space. In a sense.
Yeah, I don't know if they would say it that way, but
because empty space, right? Would the vacuum of space be more? It's more space than what matter takes up in the expanse of the universe.
Empty space?
Well, space, like the space
between
matter.
There's more space than there is matter, right? Like,
yeah,
the emptiness between our star and the next star is like vast.
Mm-hmm. My thought was that, just offhand, is that because we know about, well, we don't know about, but we are starting to understand quantum particles and the quantum realm and all this. And is it possible? Maybe it's possible that the space itself has mass. It's just maybe it has more mass. Maybe it actually attracts more than we initially thought. Maybe.
So you're saying
in the quantum realm,
just the vacuum of space itself is somehow attracting stuff?
Yeah, like it's almost it's like a viscous thing, but it's on a totally different level.
Oh, are you talking about the theory that I was talking about before with the like that Einstein's intuition?
Yeah, the Einstein's intuition thing.
Yeah, we're gonna do a whole episode on that.
Yeah.
Like in short, it's basically this idea that like, so All right.
In short.
In short, in short, basically, is like, what if space itself is some sort of like fluid or material? Because we know from quantum physics that you can't divide. There's a minimum amount of space. It's called a Planck length.
Yeah.
And below that, what we mean by the word space doesn't exactly even mean the same. Like, we don't even know that there's anything less than that. Like, that's the minimum.
Right. Is it infinitely, like, divisible?
Right. So you always see these, like, when they're talking about like, relativity and stuff, we've all seen the graphic of, like,
the sheet.
You take like a flexible sheet and you throw a bowling ball on there.
Elastic sheet, and then you put something massive in there.
And then you take like a smaller ball and you kind of like flick it across and it will quote unquote orbit the bowling ball in the middle because it deforms the sheet. Which is all fine except for the fact that like that is a 2D demonstration of what is supposed to be a 3D effect, and I've never until this like quote unquote Einstein's intuition theory never actually saw an explanation for how does space deform in 3 dimensions.
Yeah, what would that even look like? Because obviously we're looking like in that demonstration, we're looking at a flat thing in a 3-dimensional world. So it's intuitive, like you can grasp the basic idea of it, but it doesn't explain what it would materialize in a 3-dimensional space.
Right. So, like, how do you visualize how space deforms, how 3D space deforms? Like, because the sheet is only a 2D example. So, the idea is, like...
Hurt my head already.
Yeah. If space is, like, imagine space as, like, little tiny, like, particles of space.
Yeah.
And that, what if you visualized it instead of deforming the way like a trampoline does, you visualize it like particles, and how particles can be more dense and less dense, and you can have like a gradient, a pressure gradient, like our atmosphere. Right. So like way up near space, our atmosphere is incredibly thin, and as you go down, the gravity of all the air molecules pushing down on the other air molecules makes it more and more dense as you come down to the surface. And then the same thing with like water, like the deeper you go, the higher more pressure is, because it's the particles themselves are more compacted.
Because of pressure itself, because of the weight of the thing.
Yeah.
Right?
Yeah. So you could essentially, that could be a tool for visualizing how space deforms. If space is these little fundamental space specks, what if the deformation is just those specks closer together?
Yeah.
Which would explain it would essentially work the same way relativity does, like, because around the sun you would have more space, and as you go out in the solar system you would have less and less of it. And so then that would affect what a straight line is. If there's more space on one side of you than the other side of you, going straight is naturally going to be a curve rather than a straight line.
So it looks like you're going in an elliptical / orbit, but in reality, that thing, that particle, that mass is going in a straight line.
It's going in a straight line through curved space.
Yeah. In a 3-dimensional thing. So in theory, like if something else massive was to just appear, it would change it in a sense of like it's the more massive thing that came into it would start to change the trajectory of it.
Right. If you were to magically,
if you're going to start thinking, if you're going to stop thinking about it as a 2-dimensional thing and more of a 3-dimensional thing, where it could be affected at any axis, essentially.
Yeah. So if you were to just like pop a new mass into existence, that would take the space around it and make it more dense around that object, so that object would start affecting other objects. And it's interesting if you think about it this way too, with like the particles of space being more and less dense. It explains gravitational waves as well, because you would essentially just be able to use the same sort of theory as pressure waves. so that when two things orbit each other, they would be making ripples through it the same way. Like if you drop a rock in a pond, it makes ripples through.
Ooh. So that would... So would the ripples... Yeah, I guess the ripples would move through the fabric, which would be this if you're visualizing it the way we were talking about, like these particles of space.
Mm-hmm.
That's the fabric.
Right.
Essentially.
Yeah.
But the ripples aren't confined to a two-dimensional thing either, so they're rippling out.
They would radiate
three-dimensionally. Right.
So yeah, that's dark matter and then our tangent, but the other side of that is dark energy. And dark energy is super interesting. So the idea and how we came with this idea of dark energy is like when we point our telescope out at all these stars in every different direction, there's this phenomenon called redshift. So you can do this in a lab. Like if you look at just like say oxygen gas and you shine a light through it and you record the light that has traveled through the oxygen will absorb, and sometimes different particles absorb, different particles emit, but it will affect the frequency of the light that you pushed through it and absorb some of those frequencies and re-emit in other places. And so there's like a specific signature of every different element and chemical and whatnot, so that you can actually look out at a star really far away and notice, oh, that's the signature of oxygen there. So but it's not where it's supposed to be. It's shifted down towards the infrared.
So that's how they figure out the
distance.
The distance, but also the composition of the objects themselves, right? Well, partially.
Well, yeah, you can use the spectroscopy to figure out the composition, but you can use it to figure out, because since you know the signature lines of, say, oxygen, you can tell that it's off a certain distance from where it's supposed to be, and so that has redshifted. It's kind of like the Doppler effect. So like when a car drives by you, as it's driving up to you, it's moving in your direction, so it's sort of compressing those sound waves.
Yeah.
And so it pushes the sound of that car up in the spectrum, so it'll sound higher frequency. And then as it goes away from you, it's leaving as it's putting those sounds out to you.
Longer.
So it's making those waves longer, so it'll go lower pitch. So that's why you get the as something drives by. So it's essentially that, but for light.
It's like the observer effect of quantum physics, but for sound almost. Because there has to be an observer for it to be shorter or longer, right? Depends on where you are observing it, where it sounds or how it sounds or looks.
I don't know what you mean by that exactly.
I mean, just that the observer effect of quantum physics is how we don't have to get into it fully here, but at this time, but the fact that there has to be an observer or an instrument picking up those waves at a certain point for it to be detected as a certain length.
Are you saying like essentially like did a tree make a sound in the forest when it fell?
Kind of, yeah.
No one was there to...
In a sense, yeah, I think so. Like, do those things even matter or have the same, like, is the fact that you're observing it changing it at all?
Well, I don't. That's
just a thought.
Above my pay grade for sure.
Yeah, no kidding. Just a thought.
Pay grade of 0.
But okay, so
dark energy.
Yeah.
Right. We're looking at these stars. We can tell the signatures in there of the different elements. We can see how far they've shifted.
Okay.
And then you look all around you, and everything is actually redshifted. If you look one direction, say you're looking straight north, all the stars there are redshifted. And then you look straight south, and all the stars there are redshifted. And then you look east and west, and all the stars in those directions are redshifted too. no matter what direction you look, everything is redshifted.
So there's something.
Yeah. But like with sound, you would expect like as the thing's approaching you, there's the quote unquote purple shift where it gets higher frequency.
Right.
And then as it's leaving, there's the red shift as it gets lower frequency.
I see.
But every direction we look, everything is red shifted. Nothing is purple shifted at all.
So it's as if everything is going the same direction.
It's as if everything is expanding.
From
everything is getting farther apart from each other. And that's why no matter what direction we look, it's all moving away from us, hence redshift.
Gotcha. Okay.
And so they use that to like determine how far away a galaxy is because they know how redshifted it is.
There's a spectrum of redshifting.
Essentially, the explanation is that as that light is traveling to us, the universe itself is expanding. And because of its expansion, it's ever so slightly elongating those waves as they travel.
Getting it.
And a longer wavelength is a lower frequency, hence redshift.
Okay. So
this is like the discovery of the expansion of the universe.
But again, they don't have the source.
Well, what they don't know is where the heck is all the energy coming from that is causing this expansion.
Right.
You know, we have basic physics telling us that every action has an equal and opposite reaction. Like you have to have some sort of energy input. If I have a ball on the table and I want it to roll, I have to push it to make it roll. That I'm inputting energy in order to cause an effect.
Is this when the Big Bang Theory came out? Is around the time that they started noticing these things?
Essentially discovering that everything's expanding, which if you run that back in time, turn the clock back.
Yeah.
If everything's expanding and you turn it back, well, everything must have been contracted at some point. Mm-hmm. And if you do the math, then at some point in the past, everything would have been contracted to the point of
the Planck,
a singularity, hence like the Big Bang. And then something caused it to go boom in the beginning.
Mm-hmm.
But what we don't know is what the heck is this source of energy that's continually causing things to accelerate?
Yeah, and don't they think it's expanding faster?
Yeah, so
now
the expansion, it's not only expanding, which is weird, but it's accelerating in its expansion. It's
not losing energy.
It's gaining. Yeah. Whatever is putting energy in to cause things to spread apart is putting more and more energy over time. But like, where is all this energy? And it's so much energy that when you combine dark matter and dark energy, and then you take a look at actual physical matter and physical energy that we can measure.
Yeah.
And you add up all the physical matter, physical energy that we can measure, and then you take that against dark matter and dark energy.
Minuscule amount.
The percentage of the universe that is dark matter and dark energy is 96%.
Holy shit.
So, according to like the most advanced science, we only have any sort of physical laws or understanding for 4% of the universe.
That'll make you feel tiny, huh?
Yeah.
Wow.
But it'll also, if you sit and ponder on that, like make you realize that science is a lot further away from explaining everything that they think they are.
Well, yeah, and then it gives a little bit more credence to the non-physical reality, like non-physical things that might happen in our universe, right?
Yeah, like
and if
how
we
much
are a
can we
ball
actually
moving
know
through
about
space,
the universe if all of our theories only explain 4% of it?
Yeah, and if we're just a ball in a solar system in a galaxy that's moving through space, who knows what energies,
faster and faster.
Yeah, and who knows what energies and what kind of anything we might encounter.
Mm-hmm.
And we have no idea. Like we talked about before, is like, you know, going back to like science not being able to prove God or the creation or right, like spirituality or spiritually, we don't know where we came from.
Sure, yeah, and you know, depends what type of scientists you talk to, right? Because like there's like plenty of super humble and open-minded scientists out there who admit how little we know, and are excited about learning it all. And then there's people that you'll hear like on these shows and whatnot, the Neil deGrasse Tysons of the world, who make it sound like we have everything. We're just maybe a few decades, maybe a couple centuries at the most away from like finishing off our theories and being able to explain literally everything.
Right.
Which is like, it's so
far from the truth.
Yeah. So,
truth is a loose term there, but
dark matter and dark energy means science can only explain 4% of the universe right now. So
we know nothing.
Right.
We know nothing.
But related to that is gravity itself. That's like the next one I wanted to go on is like
unknown.
What actually is it? What causes it? You always hear it colloquially. I always mess up that word. Colloquially.
Whatever. They know what we're trying to say.
Yeah. You always hear it described as a force. The force of gravity pulling you. But according to Einstein, once he came around, he was like, well, no, it's not that. Gravity isn't even a force. It's just the byproduct of things moving through curved space-time.
Right. It's not necessary for it to be an energy or something like that. Like having an active role. It's more the fact that it's something is moving near something else that's more dense, has more matter, more dense. Yeah, it's the better way to say it. So,
well, that's under that other theory, but so it used to be thought that there was an actual force pulling you, right? There was something that was pulling that apple off of that tree and causing it to hit the ground.
Right.
There was, and then Einstein comes along and he's like, no, what's actually happening is, the curved space-time. So like when you see a planet orbiting the sun, it's actually taking a straight line through curved space. And what that looks like is a circle.
Yeah.
Which is weird.
It's weird because we can't see it.
It's weird because we can't see it.
Can't explain it.
But
really.
We also can't.
Don't know the why.
We know it's fundamentally linked to mass, but we don't know the mechanism for that. Like, how is it that something that has mass can distort the very fabric of space-time?
Yeah, which...
Like, what is it about energy being bound into a packet of mass?
What is it that
causes space-time to curve?
What is it about space-time that allows that too, right?
Right.
Like, what is it about the space itself that allows a function of that sort?
Yeah. Like, you wouldn't necessarily think, like, oh, cool, here's this space, empty room.
Yeah.
I put a ball in it, and now the space in that empty room is a different shape.
Right.
That's counterintuitive. It's weird.
Especially to what, the limits of our like cognitive abilities. Like there might be something happening magically.
We should do a whole show on gravity, honestly, because there's so many, like we can link it to that Einstein's intuition idea. And
I think that's a good idea.
That other channel that I found.
I think we have it on one of our notes here, but we should probably link it because that's a fascinating thing, and we could go off on multiple tangents with that. Yeah, stories and whatever.
And then the next one, the next topic I got here is quantum physics itself. Yeah. More specifically, because there's actually quite a bit that we know about quantum physics. It's why we have cell phones and computers. It's our understanding of quantum physics that has given us all these modern advances.
Still limited understanding, though.
Well, it's the interpretations of the stuff. So, like, we can describe... There's a difference between describing how something works and describing why or where it comes from.
Right. You don't necessarily have to know the why to be able to use it.
You don't have to you don't have to understand that gravity is a distortion of space-time in order to understand how to throw a ball and make it land somewhere, right? Like, you can use gravity without understanding it in a similar way with our all of our study into quantum physics, we can use it.
Yeah.
That doesn't necessarily mean we know why and how and where it comes from.
Yeah,
but
the why is
specifically
always
the topic
elusive.
in quantum physics that is so argued about is this idea of wave particle duality.
Mm-hmm. There it goes again.
What's that?
Duality.
Oh, hey.
Didn't even know.
I didn't even notice.
Didn't even catch it.
So wave particle duality is this idea that a subatomic particle, or like an electron or whatever, we think it has like a packet, like it is a little dot, like a particle, but when we observe how it moves like a wave.
Right.
Which is super weird. How can something be
effect.
Both? And so that has given rise to different interpretations of quantum dynamic or quantum physics.
Yeah.
So you've got things like pilot wave theory, which is this idea that there's a sort of wave that the particle is riding on. And then you've got the many worlds interpretation, which is that that wave and all the places that the particle can be based on that wave, it actually is in all those places. It's just in different universes.
Yeah. And it doesn't stay put until you observe it.
Mm-hmm.
The idea that there are many dimensions or universes all having the same, all having a different point where that thing is.
Right.
That particle is.
That particle could have taken, trillions of different paths, and there is a universe for every one of those trillion paths that it could have taken.
Yeah. And since everything is made of particles, it leads into a lot of different theories, a lot of different
the many world stuff's weird to me. I think it's kind of out there.
Well, quantum physics is just an open door for people to just make all sorts of assumptions and come up with their own theories. And like we used to watch the What the Bleep show, and people can take the quantum physics and create whatever they want with it. Yeah,
you can definitely go woo-woo with the interpretations as well, which I think everything has its ideas to contribute to this, because we don't really have this all resolved. But what you hear, like when people talk about it, like the professors and whatnot, there's like this idea in quantum physics where like people were trying to figure out like, which is it? Is it a wave? Is it a particle? How can it be both? And people were so like wrapped up arguing with each other about the nature of it that like there became this mantra to like shut up and calculate. Like we know the math, we can use the math to like do useful things. Yeah. And as long as you guys are sitting here philosophizing about is it a wave or a particle, we're not getting anything done. So shut up and calculate. So they kind of moved on from trying to explain this stuff and was just like, all right, well, here's the math. We don't know what it means, but what can we do with this now?
That kind of explains the nature of physics and philosophy and how they kind of had a little bit of a breakup. Yeah, in a sense.
Well, because physics started out like the original name for what we now call physics back in like ancient Greece was natural philosophy. It was actually philosophers that were the ones who figured out how the world works and connected all the dots of this causing that and whatnot. And it was the realm of natural philosophy that was the origins of our Western natural science. Law. But on the other part on quantum physics is this challenge. Like we have this quantum physics that explains the small. We've got this gravity that explains the very large, but they don't work well together. In fact, they're incompatible currently. And so the other area where science is struggling is trying to figure out how do you combine small and the large? How do you combine quantum physics
What's
and
the
gravity?
connection?
And that's where you get all these other theories that you hear people talking about, string theory and And what else? So many I can't even think about them right now. But.
Yeah. What was the discovery? Like, what was it that we realized with the Higgs boson?
So there's quantum physics is trying to figure out what is. So at one point in time, someone first hypothesized this idea of an atom that like this matter, all this stuff we interact with is made of these little fundamental units called atoms. And for a long time, we thought that was the fundamental unit. And then later on, it was discovered that unit called the atom is actually made up of components. You got the protons and the neutrons and the electrons. And then they thought those were the fundamental particles. Right. But then we finally discovered that no, they're not. Protons and neutrons are actually made up of these things called quarks. And so it's in the quest to like explain all the very small things. Like what is the most fundamental unit? And they build these big particle accelerators to just
bash them together.
Take all this matter and bash it together so it breaks apart. And while it breaks apart, they can make measurements and use their theories to figure out what is it that's coming out of those explosions, basically.
So with the Higgs boson is when they discovered that there's even smaller shit. Yeah,
so with the particle accelerators, they started classifying all the stuff that was coming out of those experiments, and they created something called the Standard Model. And the Standard Model is like, I forget what it is, like 16 or 20 something different types of particles.
Quarks being one of them.
Quarks, yeah. There's different types of quarks though. There's like strange quarks and
they just
up
named
quarks
them
and down quarks. And,
right.
Yeah.
It almost is like.
And there's
computer code for explaining the movement of them.
Yeah. Well, right? It's like these are the little tiny pieces that make up the protons and neutrons, and so like even electrons, like that's one of the fundamental particles. Like we've discovered that you can't break those apart, so that's fundamental.
Okay.
And so an electron is negatively charged, and there's like basically a positively charged version of it. I think it's called a positron. So it's like the Standard Model in quantum physics is this like cataloging of all the different fundamental particles, and the Higgs boson was one that had been theorized for a long time.
What is the state of it, or what is the?
It has quote unquote been confirmed or found.
Okay.
So
do they know what it does?
It confirmed part of these theories in the Standard Model. I don't know what they all do. It's complicated stuff. But
should we look it up?
I know that protons are supposed to be like, I don't know if it's 2 up or 2 down, like 2 up quarks and a down quark or something like that. It might be the other way around. And then the neutron is like 2 down quarks and an up quark, which is weird to me because like how come 2 ups and a down make a proton, but 2 downs and an up make something that's like neutral charge? You would think
it'd be opposite.
Yeah. So I don't understand that, but
I don't think they do either.
Interesting. Oh, we're way past our break.
All right, you want to take a break real quick and
so
we'll come back and keep.
We're gonna take a break, refill our drinks.
Yeah. Crack a new beer.
Yeah, we sit here at Drew's house late at night recording while he's on dad duty, waiting for the babies to cry and calm them back down.
Shove milk down their throats.
So, we're going to refresh our drinks, make sure the babies are okay, and we'll be right back.
Enjoy the music.
drinks refilled.
Yeah.
Potty breaks in.
Yeah, the kids are asleep still.
That's good.
They're good.
Good news.
They're doing good.
Yeah, if we ever take a break like really quick after getting into a new segment or randomly, it's gonna be because of the babes.
Yeah, we'll call them baby breaks.
Yeah.
Baby breaks. The oldest one's snuggling his dogs.
So did you want to talk about what we're sipping on here?
Oh, yeah. We are drinking Rogue Brewery. It's called Bat Squatch, the hazy IPA. It's pretty good. I don't know if maybe you brought this over one before.
I don't know. I did bring another Rogue. I'm not sure if it was this one.
54 IBU. We're kind of...
That's low.
We're into craft beers.
Yeah.
I mean, we're not super snobby, but we're into craft beers. It's got a 54 IBU, and I don't know this one, but it's 12. Is that a SAM? SAM 12 or SRM? I don't know.
I don't know what that means.
I have no idea what that means. So, as you can tell, we're not super snobby.
If you know what SRM means, send us an email to hosts@dualitycheck.net.
It's got a cool little graphic on it, though. It's like a star, and it's kind of got like a gradient, so it tells you what the notes are a little bit more. It's kind of got, you see that? It's kind of got it's telling us that it's got a tropical, citrusy,
piney, bitter, and malty.
A little bit. It's not very malty.
Yeah, it's low on the malt. It's really high on the tropical and very high on the citrus.
I don't know how you define that, but it's good.
Yeah. How do you measure what are the units of tropical measure? This doesn't sound very scientific.
This one's a lot less tropically.
This leads us into our next topic. Beer measurements are bullshit.
It's all bullshit. Don't believe a thing you hear. You see on a beer can.
Yeah. They tell you how many IBUs I don't see any I's or B's or U's in this. It just looks like liquid to me.
No, the one I care about is the ALC, the alcohol content. 6.7% by volume.
Our dad, every time we give him a beer, his very first question, what's the percentage?
What's the percentage on that one?
Or if he gets a beer, he's like, ooh, this is really good. It's 9.7.
Yeah. That's his first thing he wants to talk about it. Yeah, it's 7.0 or higher for him.
Yeah.
He wants to have one beer and feel good.
Right. I mean, I get it. His beer's bloating.
Yeah, no, I get it. I love it, though, so I'm going to drink more than one.
All right, so we talked about dark matter, dark energy, gravity. We were kind of in quantum physics, but... you
can never get out of quantum physics.
Yeah, that's a rabbit hole. Let's, I guess, go on from there, because the next big topic that science is really struggling with today is consciousness itself. So you hear people throw around this term, the hard problem of consciousness.
Yeah, what does that even mean?
So I guess that's like a distinction between the quote unquote easy problem, which doesn't sound very easy to me.
So it's easy to somebody, I'm sure.
The quote unquote easy problem, the thing that we can just apply our known scientific methods to, is how does the brain work? Right? So we can hook up a brain to all these different sensors and fMRIs and all of these technologies to tell what areas of the brain are lighting up that are associated with different states of mind, different experiences.
Senses.
Yeah, so you can have someone put their brain in this machine and then smell chocolate and see what part of the brain lights up. And then you can make them smell a beer in a different part of the brain, but in the same region, the olfactory region or whatever, will light up. And so you can kind of start making this map of where in the brain are their associations with different things. You can start to build a theory for how the brain works. But no matter how much measurement you do, no matter what fancy machines you hook up, what you can't explain with science
is the why.
Is, you can't explain what makes something what it is, right? So you can't explain the experience of looking at something red and experiencing it as red.
Or that it's actually red either.
We can say that object is reflecting a certain wavelength of light that hits our retina and the rods and cones and goes to the brain and it processes it. But you can't explain why we experience that as something that we call red.
Right. Well, and you got to think of colorblind people too, right? They don't experience colors the same as everybody else. And it kind of makes me think, like, are we even looking
Yeah,
at
but that's
the
like
same
on
thing?
the easy side of consciousness, right? So like
Sure. Yeah.
color blindness, the
We
science
know
can show that like they have a
what's
certain
happening.
type of
Cones and
it's
rods.
cones that are for color, I believe.
Yeah.
They'll have only two. There's 3 types of cones. There's the red detective cones, the green and the blue detecting cones.
Right.
And for colorblind people, they'll only have 2 types or a lower number of the third type, so they can't experience the full color spectrum that the rest of us can.
I guess what I was getting at, that makes sense. Like, you can explain that, but you can't explain, like, so I guess it comes to more of like conditioning, right? So like when you learn about colors, if your brain is like, let's say I'm looking at, like, as a child learning colors, I'm looking at a color blue, but somebody tells me that color is red long enough, I start associating blue with the color red.
Right.
So I am looking at something that to somebody else, if they were looking through my exact same eyes, would be blue. But I know it as red because I've been told that color is red for so long. Mm-hmm, mm-hmm. So, like, how do
so you're saying
you can't explain that.
It's like that philosophical conundrum is like, how do we know that what I call red and what you call red, that we're actually experiencing the same thing?
Color.
Yeah.
The same experience.
What looks like
happening.
red to me might look like blue to you, but because we use the same term red,
Yeah. Right.
you call it that, even though you may experience it differently.
Right.
That's interesting.
The experience could be completely different.
Yeah. Yeah. And how would you know that?
And how would you know?
Yeah. Well, it's similar. Like, so the hard problem is like, what we can't explain what creates this idea of being inside and looking out through these windows into the world. Like, you can't explain what it's like to exist. You can't explain what it's like to experience red, experience the smell of coffee, experience the taste of a beer. Like, we can't explain the phenomenon of the experience.
Yeah.
We can explain mechanistically what inputs are going into the brain. We can explain mechanistically what parts of the brain are lighting up and interacting. Yeah. In fact, you can even look at the brain, and based on, like, they're advanced enough now that you, like, based on what areas are lighting up, you can make predictions about what experience they may be having. But you can't explain the feeling
of what's actually happening.
Right.
Because each person is different. Everybody's had a different upbringing. Everybody's had a different like the brain itself is programmable. Mm-hmm. We know like that
a self-adapting system.
Yeah, we know that intuitively because we are the thing attached to our, we're the thing experiencing it through everything through our brains, and all the inputs we have all go through the brain. Mm-hmm. So we understand that the brain, has that quality, but we don't know that anybody else is experiencing things the same way. You can't know that. You assume it based on the guidelines laid out in front of you by history, by teachers, by, all of your mentors throughout life. But that doesn't mean that they understand what you're going through, what you're feeling, what you're experiencing. Just because they can give you a rough idea of how you should, what you should be experiencing, I guess.
Yeah, I find it interesting because, like, I think we are getting to a point in history of science and technology that we're starting to approach where technology is going to start helping us answer these questions. Like, as we're creating things like AI as we're creating things like these brain computer interfaces, there will, as people are trying to like actively work on the problem of like, is it possible to upload a brain into a computer?
Neuralink, putting a chip in your brain that interfaces with it, and maybe you'll get some kind of insight as to what's actually happening.
Yeah, like maybe it will start to help us scratch at that hard problem a little bit.
Yeah.
Well, and there's the other conundrum is like, so like, you know, like the idea of like teleportation, like in theory, if you could come up with a technology that could like totally perfectly scan your body, store exactly what atoms are in what arrangement at what given point in time, and beam that across the universe to something that receives it and then constructs an exact duplicate, kind of like the Star Trek teleporters or whatever. What do they call them? I think they were transporters or whatever.
Yeah, something like that.
Whatever.
They had a different name for them because they didn't have the technology
for it.
They didn't have the technology to. It's funny. Just side note, it's funny watching those older sci-fis because they tried so hard to predict. And they got pretty close.
Well, yeah, like I mean,
but their terminology, the way they
Star Trek wasn't
it,
super far off with like their idea of like a communicator.
Right.
Like we all walk around with communicators now.
Yeah.
But they're way more advanced and powerful than they thought they would be.
Yep.
Or had the ability to envision.
And they called them different things and like all that kind of stuff. But
no, but the reason I brought up the teleportation is because like once you're reassembled on, you know, another planet somewhere, is that you?
I mean, intuitively, I would say no.
And that gets to the heart of the matter of this argument, right? Is like, if all you are is a collection of atoms arranged in a particular pattern, as like some schools of thought in modern science seem to believe that you can break everything down to the material, and that all we are is a complex collection of material. So according to that theory, if you did do that to transport you to another planet, like that would be you. It would just be a duplicate you, I guess.
Well, it'd almost be like, in this, like you would have to assume that if we got to that point, we wouldn't be burdened deterioration of our atoms anymore. Right? Because slowly.
Sure.
Like,
yeah. If you have the ability to just create something from scratch.
Because
like
if you have that ability, that means you're basically have the ability to stop what you are at that moment and transport it back in time. Because if you're moving.
But are you like killing Drew and then a new Drew is born?
Drew 2.0 is born.
Or is it like the experience of like going to sleep at night where you have a disconnection in your consciousness and you wake up and it resumes, you know, like,
yeah, like you falling asleep is your consciousness transporting to a Drew, you know, a side Drew, a different Drew in a different dimension, but same physically.
Yeah.
I look the same.
Or what would actually happen is like your experience when you step in that teleporter is, I'm dead. I just got torn apart atom by atom. And then somewhere else, a new Drew is put into a place, because like the other theory is like that there's some sort of special intangible thing that makes you, right? Like there's a ghost in the machine, that it's like the metaphor of like a video game, right? Like, you know, there's this avatar character in a virtual world running around shooting people, but in actual fact, it's you.
It's me, Drew, sitting behind my desk.
It's you, a nerd, sitting behind your desk, like putting inputs into a controller that then maps to that world, right?
And when I die, I just get off and rage. But yeah, no, I mean that would.
So like, if it's more of that second theory, right? Like,
there's an ultimate consciousness.
By disassembling you here and reassembling you over there, then if the second theory is true, then it would just be a lump of matter without a soul in it. Or
the soul is the dark energy.
Maybe the soul can detect that it got rebuilt somewhere else and will move over there.
Yeah, but like I was going to say, is the soul in my personal, like, well, the way I'm kind of piecing my philosophy together is like the soul is a eternal force, I guess you would call it, but it almost would be something like a dark matter or a dark energy that can't be explained, but it reaches out to the ends of the, if I was to be reassembled somewhere else and my matter, this configuration of atoms was to be somewhere else, then that soul is just, it's like being able to control your fingers. Like, you have full control of them, but you don't have to consciously think about it. Like you're constantly, I guess, multiverse. Like it'd be like a multiverse where there's almost like a singular consciousness behind it. Behind all of the different smaller consciousness, if you were to think about like a video game theory.
But like if we have a teleporter here on Earth and one on Mars, and they beam you to Mars
instead of the multiverse,
what happens to your soul? Does it move over there and like attach to the new body? Because then what happens if like the teleporter on Earth, when we're sending you to Mars, it breaks in the middle? So it reads you perfectly and transmits you, but then it doesn't destroy the material here. So now there's two duplicate copies of Drew. What happens?
Split personality disorder.
Yeah, like, because if there's a soul, like, you would think, like, well, maybe the soul somehow splits, or maybe the soul would go to one and not the other, and the other one would just be like a dead hump of. It would be like a person who's like clinically alive, but is like a vegetative state for the rest of their life. Like, would that be the one on Mars is like just
never
a vegetable?
Actually received the thing it needs to?
Yeah, like it's a body with no driver,
or it's a body with a driver, but there's still no like. There's like it's almost it's an avatar of you, but it's not a conscious avatar. It still has the same functions. It can still do day-to-day tasks, but it's not a soul. In a sense of, because we don't really know what
I kind of lean towards that theory myself.
Yeah, because like we don't really understand like there are people, and I'm sure we've all experienced people that look like they're just on autopilot.
Yeah,
and they don't seem to have much function going on. Like much real thought, like much real like or I don't know how to explain it, but like they're not taking conscious control of their life. They're just living it, and they're just letting things happen to them, and they're not, they don't seem to have much control over what's going on in the moment. So
yeah, the way I've been thinking about this topic recently is like, so what if what it actually is that, so yeah, we have this human body. It's this collection of cells. And for them, they're this community that lives together, communicates together. They're sharing their resources. They're sending signals all over to let the other ones know what's happening. And then the brain itself, it does receive all these inputs, and it lights up and flashes different parts of the brain. But that could just be like an antenna to your spirits, so that it's telling your spirit what's happening, and your spirit is inputting back into the brain what it wants to happen.
Yeah.
But it may explain like this idea of like a conscious and subconscious. Like, what if the subconscious is essentially like the body without the soul, right?
Yeah.
Like it's the thing taking in all this stuff. It's the thing, like the brain, it's the brain. The subconscious is the brain, and the conscious is the spirit. Yeah.
And the conscious is how all of the information gets disseminated to make sense and to be actionable to this body.
Yeah.
Like if there's other bodies with different, with other brains that maybe have a different tuned antenna because it's in a different space, it's at a different time, it needs different information to survive. Right. So if we talk about like reincarnation, maybe, right. If you go to the example of like reincarnation, like if we are all like constantly, like if time
we're going to do an episode on that, by the way.
We're going to do an episode on a lot of this. This is kind of a tangent, but like, if you are, if time is constant, like if it's a loop and it's just always happening all at once, right? So the past, present, future is all happening at once, and you have an incarnation in all of time,
Yeah.
then every tuning, every physical every physical body that you have drew, the Drews of the past or the Deans of the past all have different tuning because they need different information, and they need to take in different things and be able to act on different things based on what's going on in their environment, past, present, and future, whatever that environment might be.
Yeah, that whole idea of like simultaneous time is really interesting.
Yeah, we'll definitely do an episode on that.
You get a lot of people with like hallucinogenic experiences or people with like visionary experiences like shamans and stuff talking about how time is an illusion.
Yeah, and even without spirit.
Even science, like a lot of science talks about like it makes no sense why there's a arrow of time.
Yeah, why it's linear.
Yeah.
I mean, even without
in both directions,
even without psychedelics, right? Like, there's people who do yoga or whatever, Kundalini,
and they have this sort of experience of like leaving their body, or tapping into
their higher body of their higher body of knowledge, or like that recent episode of Brothers of the Serpent where they talked to that chick.
Oh yeah. What was that?
And she basically does, what was the,
that is episode 300, the Akashic Records and Ancestral Magic with this, her name was Heather Shy.
Yeah, Heather Shy. And does it have a little snippet of what she does on there too? Because I can't think of the name of what she does.
Like healing and like astrology type stuff.
Yeah, and
basically helps people go on like healing journeys. Or she's
a certified hypnotist too.
Records. Yeah, she uses hypnotism.
Yeah, so look up Akashic Records, and
check out Brothers of Serpent.
Brothers of Serpent podcast is great. We both love
it. Similarities you notice between our podcast and theirs is totally coincidental.
There's no right. We definitely didn't take any inspiration from them whatsoever.
No, not at all.
But that was a fascinating topic that she was talking about. And I'd love to. Our sister does some stuff like that. She does crystal healing, and she does birth charts, and she's very in tune with that aspect of life.
I have such a weird relationship with those topics. Like I through my life have gone back and forth between hard science atheism and
full on spiritualism,
full on new age woo woo spiritualism, and I've got this BS meter that starts going off in my head when I hear people using certain terms and whatnot. And I'm can you actually explain this? Or what is the actual theory behind this?
I mean,
but I'm trying to be open-minded.
Well, it's like what we talked about. Science can't do anything better for us a lot of the times with a lot of this stuff.
Right, we're talking about all of its limits. And in fact, I've actually found some sort of middle road, the duality.
Yep.
Where I actually believe what a lot of people would consider to be very woo-woo stuff, but we'll get into a lot of that stuff in good time. Oh, on the topic of consciousness, there's a lot of really interesting illusions that kind of help show that what you actually experience is some sort of weird amalgamation of what your brain actually creates. When you look out of your eyes and you see the world, what you're seeing, what you're perceiving is not what is coming into your brain.
Right. It's a dumbed down version of all of the actual information being processed.
Mm-hmm. And some of it's straight up fabricated.
Right. Because your brain wants to fill in the gaps to.
Yeah. So there's this, so you can actually test this at home, guys. What you want to do is you want to take a white piece of paper. Do you have paper around here? You should do this.
Yeah, I'll do it right now.
Okay. Do you have anything that's not lined? It may not work with lines.
I'll use this.
There you go. All right. Take a plain white piece of paper,
Okay.
put a black dot in the middle of it.
Oh, yeah, I know where you're going with this. Okay.
Yeah. Okay. Now, what I want you to do is hold that in front of yourself and close one eye.
Okay, you might not be able to hear me, but we'll do this.
Okay. Now, if you move it around, you might have to move it a little closer and farther, but there's a certain sweet spot if you get it directly into the part of your vision where the stem of your eye connects to the eyeball. There's actually no rods and cones there, and your eye can't actually detect that dot. I think you have to hold it a little further out and make sure one eye's closed. Just
Do you think the computer screens are affecting me at all?
If you get it right in the sweet spot, it will disappear. So essentially what's happening is there's this point in your field of vision where your brain fills in the blank. And if you have both eyes open, it can kind of use information from one eye to fill in the blank in the other eye. But if you have only one eye open, you can actually find the sweet spot. It's a little easier. I found it easier if you have it face down and then you can kind of move your head over it. I know it's hard to do with the microphone.
Stand up. Hold up. Glasses on.
So try that at home. And maybe even look it up online to get better directions on how to do it. But I've done it multiple times. You can actually get the dot to disappear if you put it right in the perfect spot.
Well, I know that if I move it over to where my other eye would pick it up, obviously it disappears. But yeah, I haven't found the sweet spot yet. I'm gonna keep working on it.
Yeah,
it's my homework over the weekend.
Mm-hmm. There's another illusion where. For people who have the ability to flip your tongue upside down, you can flip your tongue and kind of bite down on it so the left side of your tongue is on the right and the right side of your tongue is on the left. And then if you touch what is now on the right side, you will actually feel it on the right side, even though it's the left side of your tongue, and you should be feeling it as the left side of your tongue, but you will still feel it as the right side of your tongue. It's really weird.
Yeah, it's almost like I can't do it, but I understand the principle of it.
Yeah.
It's almost like the right side of your brain or body is picking it up now. Like, because you're moving it from your left side to your right side, now the neurons that are being fired are still in, it's still flipping, right? In space.
It's flipping in space, but your perception isn't flipping.
Right. Because
the brain never evolved to need to detect the difference between the left side and the right side of your tongue. And so
it's going to. Yeah. After we get done with it.
It's weird.
I can't flip my tongue though. Damn.
Yeah. He looks like a funny trying though.
I could make a taco.
That reminds me. So our family has this weird trait where we can shake our eyes. You just kind of go partially cross-eyed and put a little pressure in your eyes while eyeballs start shaking. And we used to have our great grandma try and do it, and every time it just looked like her face would start vibrating, her cheeks would vibrate.
She stopped breathing, and she's just focusing all of her energy to try to make it happen.
Yeah, it looks like she's just trying to take a poo. It was the funniest thing ever.
And her whole face would just go just shaking violently. And I can't do it. I can't make them shake.
You can't? I thought you could.
I can't. I'm the odd man out.
You're the black sheep.
I can cross one eye instead of both eyes.
Oh. Yeah, you definitely look weird doing that.
Isn't that weird?
Yeah.
Like most people, when you go to cross your eye, you cross both eyes
at
the same time, simultaneously. Mine is one eye. I don't know.
That's probably why you can't do it.
Maybe.
Yeah.
Maybe.
All right, here's one more. So if you're driving, obviously don't do this or pause it and wait till you're till you're in a safe spot
at your destination.
What we want you to do is have a look around the room that you're sitting in or wherever you find yourself, and I want you to take note mentally. Try and remember every single thing you see that is red. So do that now. Look around. Try and get a running list in your head. Everything that you see that has just even a little bit of red. You doing it?
Yep.
Are you ready? All right. Now
I'm ready.
Close your eyes. And I want you to tell me everything that is green, and don't open your eyes.
Yeah. And
can you think of anything in here that's green?
I mean, the only thing I know for sure is this Rubik's Cube sitting in front of me. Has green on it. I don't even know that it's facing the the green's not even facing me, but I know it has green on it.
Right. So, and what that illustrates is this thing that the brain does where I think this is personally related to what people experience as the law of attraction, where essentially if you set your sights on something, you concentrate on something enough, your brain goes to work trying to pull all the instances of that it sees in the world. And so had I asked you to name the stuff that was red, you could have named a good amount of stuff.
I was ready to.
Yeah.
I was ready to point to them too. With my eyes closed.
Right. But because I instead asked you about the green while you were focused on the red, you don't have any of that stuff in your brain, even though you just combed the entire room. So your brain is doing all this cataloging for you because you asked it to focus on something. And it will deliver what you focus on. Yeah. It's very similar. Like, it's essentially why, like, when you buy a new car, all of a sudden you see that car everywhere.
Or when I named my son.
Your brain is tuned into that car now.
Yeah.
And so it will present instances where you see that car. Okay. Whereas when you didn't have that car, you wouldn't even thinking about getting that car. You don't notice that car being everywhere.
When I named my son Wyatt, I knew there was people who named Wyatt, but I had never heard, like, never been around, never, like, it never registered as, like, people, Wyatt, like, right. But now every place, every single park, everywhere we go, it just seems like there's a kid named Wyatt. Every time. And I'm like, what is going on? And it's the same. Yeah. I mean, because I've definitely felt that phenomenon when I buy a car. I had an Isuzu Rodeo. Who the hell has an Isuzu Rodeo? But I saw them everywhere. Every single place I went, I saw an Isuzu Rodeo. I'm like, this is crazy.
Yep. And once I got my car, in fact, like, I mean, there's probably something qualitatively different between the wholeness of what people describe as the law of attraction, because, like, it's a little different to, like, start seeing a bunch of it, and it's a whole nother thing is, like, the instant it came to your head, like, there it is.
There it is, yeah.
Like, it doesn't explain, like, you and me talking about someone and then all of a sudden that person calls you tomorrow. Like, that doesn't explain that. Like, there's something weird happening there. But it can, like, explain a subset of that phenomenon where you do start focusing on it and then all of a sudden you see examples of it. And so it's actually really a powerful thing to do. Yeah. So even though science will say, oh, this law of attraction, oh, that's just a bunch of woo-woo BS, like, there actually is, at the very least, there is some known truth to it, which is the fact that your brain will do work for you based on whatever you want it to focus on.
Wow.
It's kind of like the idea, too, like, have you ever had the experience where there's, like, a problem you're chewing on or something, and then you go to bed and you wake up and you're like, oh, that's the solution.
Yep.
Your brain can work on stuff even when you're not consciously doing it.
Nowadays, it's going to be hard to decipher with all this new technology that's listening into everything. AI listening to your conversations.
Is it the law of attraction, or is it Alexa being a freaking creepo spy?
Listening to everything, waiting for me to say, hey, Alexa.
Oh, yeah. Sorry if I woke your Alexas up. Alexa. Hey, Alexa.
Hey, Alexa. Hey, Alexa, sing me a song.
All right, let's move on to another one. So that's consciousness.
You want to talk about hard and soft sciences after that, or do you want to go?
I want to talk about the limits of science in the field of archaeology.
Okay.
So, which that is hard and soft science, is that topic. So So hard sciences, what is a hard science and what are the soft science? What are the like / humanities or what they're called, right?
Mm-hmm.
So on the hard science, like physics,
mathematics.
Well, math is more of a subset of philosophy, I would say, than a science, because you can't exactly test it in the same way.
Okay, yeah, I guess that's true.
But
you could put a bunch of number blocks together.
Well, yeah, but like physics, biology, neurology.
Yeah. I'm with you.
Yeah, where you're trying to figure out how the natural world works. It's totally different than these softer sciences / humanities, because if you apply the scientific method to the natural sciences, the hard sciences, you will get back data from the real world itself.
Yeah.
Which, if you do a good job in your experiment design and not getting tricked by the data and not like reading
biased.
things into the
not being biased,
all this stuff, you can get out truth.
Right.
Or at least you can help eliminate lies and come to a little bit better understanding of how the world works.
Might upgrade to a theory.
Yeah, one day. But in the humanities or the soft sciences, you can't coax the truth out in the same way. So you can't design an experiment for whether or not Roman society was this way or that way. What we do instead is you can just dig up stuff. You can do some tests on the stuff, right? That you can use actual scientific tests like carbon dating and
sure. But you can't know what the society itself was like.
Right. So no matter what artifacts you dig up, no matter what like murals and paintings and even writings, none of that will actually tell you what the day-to-day life was like,
for an average
you can kind of
Egyptian.
piece stuff together, but there is no like objective truth right answer out there that we can actually directly access with an experiment the same way that you can do with physics.
Right. Like that's why, when you look at archaeology and history and stuff, that we're painting a picture of what it looked like based on the artifacts we're finding.
Right. So we do get certain data points, like we know that
they wore this kind of
particular
clothes.
Tool returned this result, giving it this sort of estimated date. You know that this writing is claimed at least to have been written by this person in this area.
Whether that's fact or whether that's derived from some kind of truth or if it was some kind of fiction that somebody wrote.
Right. So you end up with all these like different data points, and then the job of the archaeologist is to then weave that
hopefully
into a story that explains all those things in the best way possible.
Mm-hmm.
But it's just a story.
It's a story.
And there could be infinite number of different stories that incorporate all this stuff in different ways. And then you can maybe make some predictions that maybe some digs later will
confirm or deny.
Yeah, but you can't get straight at the truth the same way you can with the hard sciences.
Yeah, you can't prove it. You can't prove it. All you can do is speculate. It's all speculation.
Another example of that is like psychology.
Yep.
So psychology, it's like trying to figure out like how the brain works, but more on the conscious side of things rather
Human
than
side
like
of it.
neuroscience, where it's like the actual neuron connections and how does the brain physically work. This is more like how does the human psyche work?
Yeah. Like
And
what
are human motivations? And
what are the physical repercussions for what's happening psychologically in a certain person, right?
Right.
Like what is the action that they're taking based on the things that they're saying, the things that we can determine based on their medications or their history or their nurture, their person, the whole nurture nature type thing.
And the thing with psychology is like the best tool they have for like sussing out the truth of like, what is it that humans actually think about this or that is like surveying humans. But the thing is like humans can be wrong about what they think.
They can lie.
I have many times in the past like been wrong about why I think or feel a certain way about my own brain.
Right.
So when I answer someone's survey, like
You're doing it to the best of your
Even if I'm
knowledge
not
in the moment.
lying per se, like I may be misleading because I may not have that understanding.
Yeah, about what it is that you're feeling or
But
what it is that you're experiencing.
Then there's also lying, and then there's also
lying,
people
and
being too shy to admit the truth, and
yeah,
just telling people what they think people want to hear.
Yeah.
And so all of these sorts of issues can creep in, which makes it one of the, soft sciences because
you can't put
there's no objective
weight
way
to it.
Yeah, like until one day we have some sort of sci-fi way where you can like put on a VR helmet and be inside someone else's head, hear their thoughts, see what they see, smell what they smell. Like you can't know for sure that what someone else is reporting about their own psyche is actually the truth or the fact.
Right.
And so,
well, and even still, right? So if you could read somebody's mind, it doesn't mean that what they are thinking
is what they
is the objective
believe.
Truth.
Yeah. Right.
Of what's happening inside their head.
Right. So,
yeah,
because you can see an event and be like, what I'm seeing is some guy being an asshole cutting me off in traffic. And what someone else seeing that is like, maybe they have a different perspective and they're like, oh no, I see a guy who needed to get over here and tried to squeeze in,
yeah. That's more of a fourth dimensional type of
there is no objective truth in some
observation
situations about like the narrative that we make up in our heads about what's happening.
Yeah, the way we perceive everything is totally subjective to your experience and everything that's happening to you that day, perhaps, and it's all kind of just up in the air and flowing because you just can't prove what somebody's experiencing, what they're telling you is fact. Even they can't prove it to you. They can't tell you. They can't give you enough information about the way they feel to make you certain that that's the way they feel.
Right.
It's just not possible.
Right. We're coming up on our break here.
Okay.
We got time. Do you
want to take a break?
No, we got like 10 minutes or so, I think. Maybe
okay.
5. Anyway.
You can keep going a little bit.
Yeah. So I brought up the hard sciences in order to point out archaeology, right? So specifically, you can see this in places like Egypt, where you see, and I highly recommend the work of the Van Kerkwick, I think.
Yeah, from Uncharted X.
From Uncharted X YouTube channel. He's got this great series called A Tale of Two Industries.
Yeah.
Which is fantastic. Essentially, what you see when you look back in ancient Egypt is, so there was no one's disputing, not even us people into the weird, that there was these dynastic ancient Egyptians who were in the Bronze Age who could manipulate copper. They didn't have steel yet. They didn't even have the wheel,
right?
Until much later.
They're primitive. I mean,
yeah,
for the most part,
they were in a certain age of human development.
Yeah, the Copper Age, if you will.
But according to their writings, they inherited their tradition from the gods, from the early times, from the Zep Tepi,
the ancient ones. I just made that up.
And essentially you see two different types of things. So what are acknowledged as some of the oldest stuff in Egypt are actually the highest technological achievements. So the Sphinx, the Great Pyramids, and you can actually see examples of how it's different technology. If you go out and look in the quarries where a lot of the stone was quarried from, you can see two different types of quarrying happening. You can see quarrying that is done with copper chisels.
Yeah.
And there's all this like evidence left over of the use of the copper chisels and the tools and all the like dust that's made in doing that.
Right.
And you can see the tooling marks on the stone itself that looks like chisel patterns. And then there's this other type of quarrying where it looks like ice cream scoops.
Yeah.
Yeah, it literally
The
looks like
scoops.
the way your ice cream looks when you scoop it out of the tin, like what's left in the tin.
Yep.
That's what
Little
the rock
semicircle,
looks like.
partial circle, your partially circular motions, if you will. Like it's like you took your hand through sand and dug that out, and like that's the impression it made.
Yeah, so you have these pyramids that are built with super high precision, with like perfectly flat surfaces, with no mortar, and the stones are coming together, so you can't even get a piece of paper in between.
Yep.
You get these boxes that are like perfectly level. You get these vases that are made. Dude, the episode where he was talking about his recent appearance on Joe Rogan with Randall. He was talking about all the precision of the stone vases.
Yeah. They're granite vases.
They are granite. It was one of the hardest, most it's also brittle stone.
Right.
And these things are cut to like within hundreds or thousandths of an inch, perfectly parallel lines on different
dimensions,
sides, perfectly perpendicular on the vertical versus the horizontal. The dimensions on the left and right are perfect. The two different handles are perfect to each other.
Yep.
Like the precision is like space age precision.
Yeah. And he was on what's the one you showed me the other day? Jones. What's his first name? Chris Jones?
Yeah, Danny Jones.
Danny Jones. And he was talking about that again too, and he was talking about how like you would need like a chimera, like a computer to be able to make those types of like an ancient, like a mechanistic.
Yeah, you need a Turing machine.
Yeah, Turing machine. Yeah. That's what it was. A Turing machine to be able to make those types. And even if you did that, even if you wrote it out and you
still need to have a way for that Turing machine to then convert whatever you calculated into something physical. So you would need machining. You would need
a lathe or something like
right.
Some kind
but
of,
even a lathe can't explain like the handles, because you can't do those handles off of the jar with a lathe, because it would cut that off.
Yeah.
It's crazy. Anyway, so like you have these things. So you have these crazy perfect pyramids, but you also have these like crumbling, decrepit pyramids that are made out of like much weaker stone, smaller pieces. And then you've got these like perfect stone, mathematically perfect jars. And then you've got like clay pottery that is like painted up to look like the stone. So you have these like two levels of technology, and you think when you hear this, oh, okay, well, obviously they got better as time went on, right? Like the early Egyptians, they developed their technology and they got better and better. Except even according to Egyptologists, it's the stuff that's perfect. That's all the stuff that actually comes earlier.
Yep. It was all mimicry. It was all stuff. The older stuff was the worst stuff because they were trying to mimic.
Yeah, so you get this really great stuff, and then you get this like crap stuff that is trying to mimic the other stuff.
And that speaks in and of itself speaks of a lost technology. At least it speaks of a changing of the way the world, like maybe it was, because we all know like societies rise and fall. So at the very least, something happened to make it so that they were not as good at these things as they used to be.
Right. Like they had a certain level of technology and lost it.
Over time. Yeah.
But that's not the official story. So official Egyptology and their archaeologists, what they talk about is they basically just discount a lot of this evidence because they take whatever data points they accept and are accepted in their respectable circles, and they weave a narrative telling us about the Egypt. And what's funny is like, how they get this record of all the pharaohs?
Yeah.
Is they found this king's list.
Right.
And so they will take the word of the ancient Egyptians themselves in certain settings where they give them this king's list of who ruled after who, what are the dynasties.
Yeah.
But the thing about that king's list is it goes way further back.
Yeah.
And so what the Egyptologists have done is they said, everything before this point, that's just myth.
Right.
So they'll believe the Egyptians on this later
Up to a
part of the
certain
king's
point.
list. But when they themselves say they inherited this technology from an earlier source,
That's
from
bullshit.
the gods, from from the Zep Tepi times, and then when they actually provide you a list of the kings that ruled during that time, you don't accept that. So it just goes to show like the limitations of these soft sciences.
The biases.
They're ruled by people who have
just like
agendas.
everybody else.
They have motivations. They have desires to keep their prestigious positions. And maybe there's some darker elements that we'll
Maybe
get
there's some
into later.
financial elements to it. Maybe there's some darker elements that
Maybe there's a conspiracy.
there's probably at some level a conspiracy that makes it seem that they're definitely covering up some, maybe not even covering up, but they're just not giving the evidence that they can see in front of their face enough support.
Right.
They're not willing to accept things that they don't accept. They haven't already accepted.
Yeah,
because it
they've
doesn't
put
make
together
sense
a
for their narrative.
and they're so
Yeah.
committed to their narrative that they're willing to ignore certain evidence because they can't easily slot it into their narrative.
Right, and
that's the problem with these soft sciences is they're so human interpretation based. There's no way to you can't just catch them in a lie.
Right, and you have to trust that they are going out and they have the general population's best interest at heart.
Right.
It's just not realistic.
All right, so with that, we're going to go refill our drinks one more time. And we'll be back for the last and final segment of episode 1 of Duality Check.
That's right. Very excited.
Check.
All right. We're here, guys. Just listen to music for a minute.
All right, welcome back. We totally did not just talk for 5 minutes
we'll just
and forget to press
happen.
record.
We'll forget that happened.
And we totally, this is our first attempt at this show as well.
Yeah.
Yeah, we totally didn't do like a whole segment that we trashed.
We nailed it.
Yeah.
Just so everybody's aware. No. All right. Well, anyway.
Yeah.
I was talking about how I changed beers. Dean's still drinking the Rogue, the Bat Squatch.
Yeah.
This is good.
And
6.7.
you are drinking now?
I'm drinking the Sierra Nevada Hazy Little Thing from Sierra Nevada Brewing Company in Chico. 6.7 ABV.
Yeah. That's for you, Dad.
6.7 alcohol. It doesn't say ABV. Doesn't want us to know.
What does it have an IBU on it?
That's what I meant. IBU.
Oh.
Doesn't say ABV. Doesn't say. That's the one. It doesn't say on here.
Yeah, they don't all say that like when they do.
But I'll recycle it because it's telling me to.
Yep. Another hazy. You're going to see a lot of hazies. That seems to be like what most craft brews make as far as IPAs these days. I don't get a lot of the old school ones that I really liked. I like hoppy and piney IPAs. There's my favorite.
I remember when you first introduced me to Pliny the Younger.
Yeah.
You brought over one bottle and it was like a magical thing for me.
I don't think they make the Elder is the one you
can get pretty regularly.
Yeah.
It's the Younger is
that's
the
a special
rare.
release, and I don't know if they bottle it. I think it's only in kegs, unless you go to the brewery itself. You have to know when it's going to release and know what place to go to get it.
They only keg that? No.
I think.
Well, maybe I don't know. You definitely brought some home at one point, I feel like. Unless it was the Elder that we were drinking.
The Elder,
okay.
Yeah. Which they haven't Nugget.
Honest mistake. I was under the age. I mean, I was...
What?
No, I'm just kidding. But I was
totally
still...
didn't teach you about alcohol when you were not of age.
I mean, learning it's not a problem. Right?
I got my socks on.
Oh, God.
Inside joke.
Oh God!
And
you know, you know.
I told the story at his wedding, and he turned beet red, and I kind of felt bad afterwards.
Well, it was mostly because I looked at the audience and I was like, "Shit, there's a lot of people here that might not have wanted to hear that." But it's fine. It is totally fine. It's in the past now, or the future.
Yeah, because time is cyclical. All right, so we were talking about ancient Egypt and about archaeology and how like it's kind of a game of like painting a narrative with the little bits of data that they get here and there.
Mm-hmm.
Right, like it's a data point that there's a pyramid there.
Yeah,
right.
Well, I mean, I haven't been there. Have you been there? I don't know, but yeah.
Unless all of Google Earth is a conspiracy.
Everything
itself.
I've ever known is a lie. Okay.
Yeah. We got to grab onto something as truth.
Okay, so yes, it is a physical thing in a physical space.
But the other problem with archaeology is that there's a lot of lost knowledge, and it's heartbreaking and frustrating. Like the burning of Library of Alexandria.
Yeah.
Just how much human knowledge
and even
was destroyed.
Not to get I don't want this to mean anything politically, but like the a lot of the temples and artifacts from the Middle East that are being destroyed.
Yeah, in the Iraq War.
The Iraq War and how much that
was
devastated
lot of the
our human knowledge.
Sumerian and Babylonian artifacts that were just flat out destroyed.
For what?
The Museum of Baghdad was looted.
Yeah. Well, and even going way back, right? The pyramids themselves, the limestone casing blocks.
Yep, those were stolen.
Like the pyramid, the pictures you see, that doesn't represent what the pyramid looked like in its entirety.
It would have been smooth with like a flat surface on the side instead of a stepping surface.
Yeah.
And it would have had, it was rumored to have, or it was told in ancient sources to have had like a gold capstone. Yeah. Can you imagine if we could see it that way today? Like,
well, you can if you play Assassin's Creed.
I played that one a little bit.
Dude, you need to play that. That one's the best one, I think, because you get to roam around ancient
maybe
Egypt.
A third into it. But
anyway.
I went straight under the Sphinx. I was like, where's the library?
Yeah, dude, I did the same thing. I went straight to the pyramids. I climbed to the very top. I wrote my name.
Yep. And then I jumped off and I was like,
and then I slid down. You can slide down it. And like, dude, it's so cool. Yeah. Anyway, but just as quick.
There's just so much we've lost.
Yeah, but like a quick side note too, like there are scientists and archaeologists that are looking into how the elements of the pyramid themselves, the mainstream is that it was a tomb.
Right.
Because
the Egyptologists say that the Great Pyramid, all three of the Great Pyramids were tombs.
But though the only actual bodies they've ever found were in the much older, much easier to date.
Well, the newer pyramids.
That's
like
what I mean.
Oh,
sorry. Yeah, no, that's what I mean. The newer ones that are much easier to date, and they have humans remains in them, and there's but
along with all of the accoutrements that would go with it, like the offerings that you leave for the dead and whatnot.
Yeah, for the duat. But the three pyramids, they don't have that.
Yeah, there's
never been a tomb found.
A tomb found. There's
inside.
Never been a body found.
There's been a bunch of chambers. There's been a bunch of weirdly oriented shafts found, and there's been an aquifer,
the Orion correlation, where the three pyramids,
where they all line up
to Orion's belt.
But there's also been an aquifer found underneath the pyramids, or a river, like an underground.
Yeah, there's an
river
underground water source.
Yeah, and there's a lot of speculation to what this all means. The orientation, the construction, the fact that the king's chamber inside the pyramid is made of like multi-tonned stones quarried from 3 miles away.
No, like 500 miles away.
Okay, yeah, no. Yeah. Either way, it's far.
Yeah, and these people were supposed to move 60-ton stone without the wheel. 500 miles.
granted, there was this one guy, I can't remember his name, but I saw a couple of videos of him recently that reminded me of when I saw it originally, like years back. It was a guy who he's an engineer. He's a retired engineer.
Oh, you're talking Christopher Dunn.
Yeah. He uses the leverage of like a center point underneath the stone. It's like a leverage point, so you can rotate it, and then using like logs laid out in a certain way to like slide it over like a conveyor belt looking thing.
Oh, you're talking about no, that's not Christopher Dunn. Then you're talking about the people who are like trying to use primitive technology to
explain how the stones are moved.
Right. The problem is,
granted, there are some that make sense.
There are some, yeah, but the pace at which it would have to be done would make it like like a multi-century project.
Yeah, still hundreds of years, but just granted, that is
supposedly built in like 25 years, according to. I don't even know what the source is for that. I think,
I don't know. But still, the evidence showing like that is not a tomb. I just wanted to go on the side note that like the pyramid itself is being blocked by Zahi Hawass. Like you can't do any. I mean, and also he's the conflicts that are happening there.
Authority figure that runs the. I forget what the Egyptian Department of
Egyptology,
Antiquities or whatever.
Yeah, something like that.
He's like the official head of like everything Egyptology in Egypt. He tells people who can and can't do what projects.
He approves
all
of it.
Study the pyramids or anything in Egypt in certain ways.
Yep, one person, not a board of directors. That But anyway,
and his story is really interesting too. He actually like came from this like group of like. What were they into? They were like into like weird psychic stuff.
And he was like
they like paid for Zahi Hawass's education to like plant him in official Egyptology so they could get it in.
Yeah, well, imagine they're playing the long. Imagine they're playing the long game.
Well,
maybe he.
According to them, he turned on them, and
there's a lot of money
denied
involved.
them access too.
Yeah, maybe there's a lot of money involved, or there's just a deeper knowledge and understanding of what's going on there.
Or he got the talking to before he got that position.
Like he's like, hey, listen, do you want to know the origins of the universe?
Right.
Then shut the fuck up.
Right. Like we'll give you this knowledge for yourself, but you must.
Nobody else.
You must only allow the official story for everyone else.
Yeah, we like to talk about these things, guys. Mm-hmm. Listen, we're gonna talk about conspiracies.
Yeah,
and we're gonna talk about them a lot, and
we'll support them and we'll break them down too.
Yeah, we'll try to break them down to the best of our ability, and I think we are pretty grounded in what. Like this is why we're doing this episode specifically as first too, is like to let people know we appreciate science. We appreciate all it has to offer.
Go easy on holding the mic all the time. You're gonna get a lot of rumble that way.
There you go. Is that better? Yeah, like we're gonna go pretty heavy on it. Mm-hmm. So just the
other thing that a big loss of knowledge that we know for sure happened. Was Mayans here in the Americas. Yeah. The Spanish, when they came here, they literally went out of their way to burn every single text that the Mayans had.
Yeah.
To the point where I think we have like 3 or 4. That's it. And they had such an interesting, unique language and stuff. And just what's the wealth of knowledge that we could have gleaned from that.
From this land. The land we live in.
Someone upon high decided this was not godly. These heathens and these savages, we must destroy all their knowledge and turn them into good Christians.
Man. Yeah, the amount of knowledge that could have been. I mean, it's like, in the to grasp it, it's like, your grandparents or somebody that you've respected your whole life wanting to pass on their knowledge. It's like that, but multiplied on such a level that like there's so much about the world that they knew and had a perspective on, because these are modern anatomical humans that have the same brain. So but they have the same brain as us.
Right.
They just lived a different lifestyle.
And they had some amazing accomplishments, amazing buildings and stuff.
They had their own pyramids.
there's probably some dark stuff going on with seemingly human sacrifices and whatnot.
But the world was a different place. Right?
I want to know.
What was it all for? What did they know, or what did they think about the world and the nature of it? What experiences did they have that shaped their learning?
Yeah.
Or was it all just a dictator at the top telling people what to think from the time that humanity has started?
Right. And
that was there just a powerful person
that kind of
trying
segues
to project
into like why are we pointing all this out?
Yeah.
All these like blind spots, shortcomings, total theoretic things that science tends to portray as fact when in fact it's really just a theory.
Yeah.
And the reason is because it's important for us to know how the world works. And the people who call themselves the intellectuals, who take it upon themselves to represent us in pursuing knowledge and truth and then sharing with us, the rest of the world, on what they find, they're just humans.
Yeah.
They have all sorts of monetary and political reasons for. So one thing in the history of science, science comes out of it. I mean, it goes way back. Modern science goes back to Bacon and the Renaissance and the Enlightenment. But back before that, it was the scholastics, the Catholics, that were doing science, and before that, the Greeks and all these, But okay, I got my point back. So where I was going with that is that the roots of science, of modern science, came out of the scholastics. This was when science and religion were part of the same thing. And so it wasn't so crazy to do science and for that science to line up with the religious understandings. Right. Obviously that can lead to religious biases and lead to blind spots because of that. But at some point during the Enlightenment, when atheism and people started leaving the church and the Catholics were fragmenting into all these different religions, and people who wanted to do science, there was more and more people who were doing science who were not spiritual.
Right.
And they were trying to steer science in a direction where, no, we're going to explain these things without miracles. We're going to explain these things without God. We're going to explain these things as mechanistic. This is when this materialism worldview got started. And so there's this bias to this day in science where if something seems to be hinting at something that gives credibility to religion, we're going to try and steer away from that explanation. That is our last option for where we'll go for the explanation. And it's funny because it blows up in their face all the time. In fact, recently they just found the biblical city of Sodom.
Right.
And that it was destroyed by an airburst meteor that exploded in the atmosphere above Sodom and just leveled the city.
Right. Yeah, it was just like what happened in Tunguska.
Just like that, yeah. Another example is the city of Troy that came down in the writings of the Iliad and whatnot.
Yeah.
Homer wrote about them.
But we hadn't found it.
And everyone thought it was just a myth until someone actually found it. And so in a similar way, anytime science seems to be leading us in a direction that might give credence to spirituality and religion, everything possible is done to steer the science away from it.
Yeah.
And so all of this evidence with the Younger Dryas Impact theory, this idea that 12,800 years ago to 11,600 years ago, this period called the Younger Dryas, there was an event that happened
that wiped the earth.
That wiped the earth clean.
In a sense.
And we know that humans existed then.
Yeah, and there were some safe havens, obviously.
Right.
But the majority in this theory, the ocean levels rose by hundreds of feet.
400 feet over the Younger Dryas.
And that means that anything, if you think about where we have our cities, everything's coastal. The largest cities are all right next to the coast. So that would, and if you're talking about like a airburst, that would, if you had any type of technology that might be electrical, would have been wiped out. Like, not saying that it was.
Almost everything would have been wiped out. And my point isn't to go into the Younger Dryas on a tangent, because we're going to do a whole show.
We're definitely going to do a whole show on that, for sure.
In fact, probably multiple.
Actually, I think our next one.
Yeah, in fact, that's next episode.
That's our next episode, is that.
But the reason I bring that up is to just show that all this Younger Dryas science is... Just look at the unfair and ridiculous skepticism it's getting. Go to cometresearchgroup.com. Might be
maybe .net. Check them both.
Just Google it. You'll find them. Yeah. Or the Cosmic Tusk. Either of those websites have all this published scientific research on the Younger Dryas Impact Hypothesis. But the reason why so many scientists are against it is because this is essentially proof of the biblical flood.
Yep.
And we don't want to go there.
No. Yeah, it's proof of that, and it's also proof that there was not proof, but it's proof that there is possible that there was large societies, large
there was
civilization happening before this time.
Right.
And that it only makes sense when you talk about like the Clovis culture and how like that's like the accepted time of like human development, where we grew agriculture and we started like all like that.
Well, the Clovis
period.
is
Clovis
the people
is
in North America.
Yeah. But like that period of time is when civilization like started.
Right.
Because we started agriculture and we started all these things to start technologically advancing to the point where we can have a civilization.
Sometime maybe 50, 60, I don't know exactly the date on this part, but humans left Africa and we started spreading over Europe and Asia. And then about 12,800 years ago, before that, during the Ice Age, there was a land corridor across Asia into Alaska, and that people walked that, and that was the first peopling of the Americas.
Yeah.
And then the Ice Age ended, and that land bridge was closed because the sea levels rose and the ice went away. And so those people that were now in America were isolated. So that essentially the Native Americans all descended from essentially the people who were migrating out of Asia.
Right.
But the problem with that is we keep finding stuff that goes back before that 12,800 or before that Ice Age when the land bridge was closed again. Right. But we still find artifacts.
Yeah. Where they were supposedly heading
the San
just
Diego
came to
find
here.
that is estimated at like 200,000 years old here in America.
Dude. Yeah, that's insane. I mean, just to think that
and that the first...
And we know there were seafaring cultures. Like now we're starting to understand like a lot of these older like maps and like...
Right, like all the Polynesian islands.
Yeah.
Like these are people who traveled thousands of miles across the ocean. But the official story is that, we went out of Africa, we started populating the earth, and then the first civilizations was Samaria. I guess now Göbekli Tepe, because that's explained as like the official story on Göbekli Tepe is that was hunter-gatherers making a religious site.
Yeah. And that was the first sign of religion.
It wasn't actually civilization.
It was just a first sign of religion.
So that's because
it ritual
messes up their narrative because it's actually dated to 12,000 years ago.
It, but if you look at the sophistication of the burial of it, like because Göbekli Tepe,
I've
do
heard
your research too if you're listening to this. But Göbekli Tepe was a mound of buried artifacts.
Right.
A buried site that's, in a hill in Turkey.
It's in Turkey, and the word Göbekli Tepe in Turkish means pot-bellied hill.
Pot-bellied hill, that's right.
And it's essentially what they believe to be a deliberately buried site that dates back 12,000 years. But it's giant stonework with relief carving. So, there's difference between normal carving of pictures and what's called high relief. Is a normal carving, like if you want to draw a dog, you etch into the stone the places where the dog shape is.
Not this.
But a high relief is, instead of etching in where the dog is, you etch in everywhere where the dog is not. And what you leave is a protrusion in the shape of the dog, which is so much harder.
A 3-dimensional image of it.
So you have this super advanced carving back 12,000 years ago, right at the
end of the Younger Dryas.
Younger Dryas, right.
Right at the end. That means
that's the beginning of it. 11,600. So it'd be right around the end.
Yeah. So it's like the beginning of this supposed civilization. Like you're talking about, like you're going from like hunter-gatherer is what the accepted people were at the time, or hunter-gatherers. And they're trying to now tell us that they think hunter-gatherers were just a little bit more advanced than we thought they were, and they were able to do all these amazing things. But if you think about the division of labor,
without civilization, with no division of labor,
you have to have division of labor for that kind of thing,
right? And also, Göbekli Tepe just demonstrates all of this knowledge of the stars. We need to do an episode just on Göbekli Tepe too.
I think we could do that for sure. I mean, we could probably put that in with the Younger Dryas, but anyway, Göbekli Tepe is fascinating. Just all of the artifacts that you find there.
Exactly. The other thing I wanted to get into, but we're actually running out of time, so maybe I'll
maybe do a quick synopsis.
But the other issue with science today is this was a big hubbub about 10 years ago or so, about a decade ago. There's a really good video, I'll link it in the show notes, by Veritasium. And it's this issue in science known as the Replication Crisis. The Replication Crisis, which essentially what happened is that someone decided to do research on science itself, and they gathered a collection of scientific papers that were peer-reviewed and published in prestigious journals, the most prestigious journals, that were highly cited. So the way it works, right, is like if you're doing scientific research in a particular area, you're building on earlier knowledge. So you're going to cite the papers of that earlier knowledge in your paper. Yeah, and the more cited your paper is, the more fundamental it is, or the more credible it becomes, the more citations,
the more based in previous.
So they took highly cited, peer-reviewed in prestigious journals, and they took a sample of these papers, and they actually went through and tried to duplicate the studies.
Yep.
And I think it was like 60-70% failed. Unreplicable. So this led to this big old controversy in science. And I want to spend some time on it, but essentially you should watch the video because he does a better job, Derek.
Yeah, we'll link it in the show notes for sure. People should watch it.
But it essentially comes to a number of things with incentive issues. So scientists, in order to have a successful career, it's not about doing boring science like replication studies and negative studies showing that something that was thought was true is not true. Those types of things don't get published. Right. And so what scientists end up doing is only publishing positive results. And there's another issue called p-hacking, where essentially you take the statistical analysis, and there's lots of ways to do it, but you essentially are able to fudge the statistics in different ways in order to show a positive result where there wasn't one or shouldn't have been one.
Yeah. Isn't that because the threshold of positive of a positive result is so low or so high? I guess it would be so low.
One way to get around it would be to have a higher threshold, but there could still be the issue with that, because part of the issue,
I guess, it would be longevity.
There's multi-target studies, right? So like one way that p-hacking can work is if maybe you're looking for something, but to be safe, you're actually going to look for like a dozen different things
that would get you to.
And even if like 11 out of the 12 things you were looking for showed no statistical significance, if one of them does, all of a sudden you shift the study to being about that.
Right.
But that's not what the study was set out to prove in the first place. It was just some sort of statistic fluke you found in it.
So you can take any of those markers and call it proof for something that's completely unrelated otherwise.
Yeah. And the other thing is like the sample size issue.
Yeah.
So a lot of studies don't have the funding to do real, true statistical significant sample sizes. And so what they'll do instead is they'll do small sample sizes, or they'll cut off their data at the point where the data starts shifting in the wrong direction.
Right where it goes to the point of statistical significance, and then they stop.
Yeah. So like, for instance, let's say I had the theory that when I roll dice, I can get more than 1/6 percentage of sixes to roll.
Yeah.
Because of my mind powers. Okay.
Yeah.
And so I do a study, right? And I start rolling. And, you know, the thing with like statistics and probabilities is like, sometimes, like if you're flipping a coin, you're going to get hot. You're going to have a lot more heads in a row.
Yeah.
Right. So maybe I'm doing my study on rolling dice and I happen to get a lot of sixes in a row. It didn't even have to be sixes. Let's say I did one of these simultaneous studies. And so I'm just tracking the statistics and I roll it. And I happen to be hot on one number in particular. And this time it was a 6.
That's the number I was
and
talking about.
before I keep rolling to get way more sample size, I cut off the study and I say, boom. Our studies concluded. I run the analysis, and I just happened to capture the one point where I had a hot streak. And
it
so
could
it
be a
shows,
5 at
quote
that point,
unquote,
right?
statistical significance, even though it was a hacked study.
Yeah.
And anyway, so they kept doing research on this, and they're essentially estimating that some 70% of scientific papers are unduplicable.
Yeah. The replication crisis is definitely, but like I've heard too on other podcasts, is like there's a lot of scientists waking up to it, and there's a lot of hope. That
there's been a lot of work towards that in the last decade too.
Like people are understanding that this is a problem.
Research came out,
but
it just goes to show:
is there a now there's just an established this is right, and we have to do it this way continuously, or can we change the fundamental workings of like published studies, like that being the thing that gets you credibility in your theories, right?
I mean, in my mind, we need more decentralized publishing outlets. I mean,
Less
I don't know.
Government control.
I mean, we're in the freaking
the
internet
funding.
age. Why is everything still like controlled by publishers? There should just be decentralized blockchain-based peer review. Well, so here's the thing: just decentralized blockchain-based science paper posting.
Yeah.
Right. So you post it.
Right.
No one's reviewed it yet, but
over time,
the fact that you post it and someone else
Anybody
sees
can
it,
review it.
they can go review it, take a look on it, post a review.
Yep.
And that's how you get your peer review, by actual peers
and then people
interested.
can take that paper and do that, and then
rather
people
than
can
some political process of like this like blind peer review where you don't know what qualifications they're actually going to allow or not allow your paper based on. It's a lot of there's a lot of weird formalities in science that aren't essential to the scientific process itself. What is science? Like at its core, is science the universities? Is science the research publications? Is science like the Nobel Prize? No, those are just formalities built up around science. What science is the scientific method.
Yeah,
which is about
comes back to that. For
just
sure.
a process of finding knowledge. Yeah. Everything else is like dressing built up on around it
that
we associate
it's almost
with.
a religion built around science.
Right.
It's all the rituals that you would expect from humans to create. And it's almost any institution to give it enough time.
Right. And, you know, the funding is an issue too.
Yeah.
Government funding
is
some of the company funding is pretty shady in certain areas. Like,
well, because a lot of that can be privatized. Like they do these
just
studies
like
and get the knowledge, and then they patent it, and then they put it on a shelf and they lock it away.
It's like all the health funding done by the tobacco companies on cigarettes, right?
Yeah.
Like that's an obvious conflict of interest.
So obvious, yeah.
But like, let's say all of science, instead of government being the main channel that funds money into science, like what if it was Walmart?
Right.
Would you how much would you expect an uptick or a downtick in the amount of studies that find faulty Walmart practices or products.
Right.
You would expect a downtick.
Yeah.
Okay, what if science was overly funded by the Catholic Church? Would you expect an uptick or a downtick in things that contradict the Bible?
That's why you need to leave it funded by the public, and it needs to be funded by a population that is well aware of what's going on in science, what the actual
it just needs to not be any one particular person in control, and the government isn't a person.
Entity, yeah.
And obviously this is like conspiratorial thinking, and we can get into all that later, but
yeah, we're going to get into it.
There is a whole different set of biases that come along with government funding. Yeah. The same way you would have them with Catholic Church funding or Walmart funding science. Yeah. The fact that it's the government doesn't mean that it's unbiased.
Yeah, of course.
There are going to be biases.
It depends on the government.
Right. Anyway, there was another podcast I wanted to cover that talks about our present dark age. This guy, Steve Patterson. I'll link it in the show notes. I think you guys should check it out.
Definitely watch that one, and maybe even watch the Brothers of the Serpent podcast with Jeremy Figgins.
Yeah.
Maybe even we'll link that one.
Yeah, this was one of their listeners that wrote in, and they ended up interviewing him, and he went through this whole process of becoming an academic.
Yeah, he
talks a lot about the process of people censoring his research.
Yeah, I mean, he's got a lot of anecdotes about being in the collegiate world and what that's like, going through and writing papers and talking to professors, and I'm sure a lot of you will have as well. But it's fascinating to hear. So we'll link that one too.
And all of this is not said to make you guys think science is BS. Science is our best tool at figuring out how the world around us works. Well, at least it's the best tool figuring out how everything works materially. And
as far as spirituality goes, that's all self-discovery, and we'll get into a lot of that type of stuff too.
Yeah,
we'll talk about all of the disembodiment stuff and any type of spiritual thing that you might think of.
Yeah. So it's been fun. I think we had a successful first episode. I hope all you guys enjoyed. Hey, if you have any thoughts on the show, please write in hosts at dualitycheck.net. We're also launching our Facebook and Instagram, and neither of us are huge social media guys, so we'll do our best on that.
Figure it out.
But the email it's probably going to be the best way to get a hold of us for a little while.
Yeah, but we'll be posting as far as when we'll be doing episodes and all that kind of stuff coming up. So keep an eye out. Look for our logo. It's pretty pretty.
Yeah.
We love it.
Have some fun
Check it out.
looking at all the details in it. There's a lot of little Easter eggs.
Keep looking.
Yeah. And keep looking out at
the
world around you and learning, and have fun experiencing this crazy world we live in.
Yeah. Come back next time for some more questions to be added to. We'll just add questions to your questions.
Yeah. Because we sure as heck don't have any answers.
No.
Adios.
Later.